Stemplot is like a histogram. They are rough tools to help us visualize a data set. Stemplot shows a little bit more information than a histogram and has been a common tool for displaying data since 1970s. They are typically used when we have a minimum amount of quantitative variables to analyze. Stemplots of more than 50 observations are unusual. The name stemplot comes because there is one stem with the largest place value digit to the left of the vertical line and one leaf to the right. This is also sometimes referred to as a stem and leaf plot. There are four main components of a stem plot. The first component is the title. The second is the key. These two things allow us to read the data and tell us what is being measured in the data. So the key translates what's being measured into the actual raw data, and the title tells us what's the variable being represented on the graph. The third component is the stem, or the largest digit of our raw data sets. Notice our stems need to be in increasing order, 5, 6, 7, 8, 9, equally spaced, and no gaps in between. The last characteristics of a stem plot, of course, is the leaves. This consists of the remaining variables of our data, remaining digits of our data, or the truncated digit of our data. Notice that our leaves are also arranged into increasing order within each stem, with the smallest value closest to the vertical line and our largest value as far as way. Notice that this data translates easily back into our raw data. There are both advantages and disadvantages to a stem plot. A stem plot are useful in some cases because you can see where the bulk of the scores lie. Okay. In our above data, we can see that most of our data lies in the 80s. Okay. Bar graphs also show this information, but the advantage to stem plot is that you see all the scores. You know what your raw data is, not just the totals. These types of charts give you a quick overview of the distribution, and you can see the shape of the distribution very clearly. They are also useful in highlighting the mode and for finding outliers. But the disadvantage of a stem plot is that they are really only useful for small data sets, less than 50 data points. Dot plots are also more useful with smaller data sets, whereas if we want to deal with large data set, you're more useful to use a box plot or a histogram to represent your data. In our first example, we're going to learn how to construct a stem plot. Step 1. We will need to determine the stems of our data. To determine the stems, we need to look at our minimum and maximum value and look at the largest digit of each of those data points. By looking at the range of our data, our max and our min, we will help us figure out which stems to use. So looking at this data point, my minimum value is 50, and my maximum value is 99. So I look like my data has 50, 60, 70, 80s, and 90s in here. So I'm going to use the 5, 6, 7, 8, and 9 as my stems for my data. Step 2, once we determine our stems, we need to transpose our raw data onto our stem plot. Now this is going to be the intermediate stem plot. We're just going to get our data, our leaves put on here. So we're going to look at all the remaining digits of each data point, excluding the stem. And we're going to put it in a line with the stem that data goes with. So we're going to find the leaves for each stem by looking at the raw data. So our first data point is 64. So on the 60 row, I'm going to write a 4. 82 on the 8 row, I'm going to write a 2. 85 again on the 8 row, I'm going to write a 5. 99, row 9. 96 on row 9, I'll write a 6. Now I'm going to continue this pattern for all my data sets. Now this is not my final stem and leaf plot, but this is just how I can organize my data quickly so that I can then go to my next step, which is to write our data into increasing order. Okay, step 3, we're going to rearrange our leaves inside each stem into increasing order. So we're going to rearrange the leaves into increasing order, being very careful to make equal space between every leaf. This is very important that we make the spacing equal in between each leaf so that we can get a picture of the distribution of the data. If we write the small leaves too close together, we might distort our distribution. Okay, I'm going to write my final stem and leaf plot down here. So on the left-hand side of my vertical line, I still have my stems. So that's 5, 6, 7, 8, and 9. But then in each row, I'm going to rewrite these rows into increasing order. So looking at the row 8, I have 3 zeros, so 3 80s. And then I also have 381, so that's 3 ones. Notice I'm trying to make my spacing as equally spaced for each of these. And you continue this pattern until you have all your data into increasing order. Very important on your final stem plot that your leaves are in order. And then I'm going to repeat for row 9 for my 90s. I got a 96, a 97, a 98, and a 99. So notice that I'm very careful that I'm having all my data equally spaced. This 9's a little too close to the 8, so let me move it over so I can keep my data nice and spaced so I can look at the distribution, clear distribution of my data. Now all that's left is our last step after we have our stems and our leaves in increasing order. Last thing that we need to do is we need to identify the title of our stem plot, and then we also need to come up with the key. So write a title and a key to your stem plot, and then you will be done with your first stem plot. I wish I would have left myself a little bit more room, but I think I can fit it in here. So let's look. This was measuring 3rd grade test scores. So I'm going to title this distribution 3rd grade test scores. See if I can fit it in here. I should have left myself more room. And then I need to make a key. So on the key, I just pick one data point on here, any one, it doesn't matter which one you do. I pick the 6 line 4, and then I want to say that represents a score of 64 on the test. So notice I take the 6 vertical line 4 and translate that to 64. Sometimes it might be 6.4 or 6.40. So you need to make sure that the translation that you have, the key that you write on your stem plot, is extremely important. So because I kind of smushed it in here, I'm going to box it in black so that you can see this is actually what a stem plot looks like.